So our lesson today is about probability scales, and we are going to see how to apply probability scale to represent a chance. So what is probability? Probability is how likely something is to happen, or we can say that probability is the chance of something happening. Probability can be expressed as fractions, decimals, or percentages, and they always take value from 0 to 1. Now, when you do something such as rolling a dice, this is called an event, and the possible results of the event are called outcomes. For example, when you roll a dice, you have 6 possible outcomes because a dice is numbered from 1 to 6. So when you roll a dice, you have 6 possible outcomes. A probability scale is a simple way of showing probabilities, and it goes from 0 to 1. 0 represents impossible and 1 represents certain. Now, if something has a 0 chance of happening, then we can say that it's impossible. And if something has a 100% chance of happening, then it is certain. You will agree with me that rolling a 14 on a dice is impossible. Okay, the chance of getting a 14 when you roll a die is impossible. Okay, so in that case, the probability is 0. Now, when you flip a coin, you have an even chance. You either get the head or you get the tail. So the front part is the head and the other part is the tail. So you have an even chance, okay, and that is 1/2 half. On the other hand, it is certain that the sun will rise tomorrow. So the probability that the sun will rise tomorrow is 1. So these are some of the language of probability. We have impossible, unlikely, even chance, likely, and certain. So we're given 5 statements. Let's take a look at where these statements fall on the probability scale. So I'm going to start with the first one. It says, what is the probability that the sun will rise tomorrow? That's certain. The second one says, what is the probability that you will live up to 500? That's impossible. What is the probability that when you spin a coin, you will get a tail? When you spin a coin, you either get a head or a tail. So that's an even chance. What is the probability that you will see a bus on your way to the mall? That's very likely that you see a bus on your way to the mall. And the last one says, what is the probability that the next car that will drive past your house will be green? That's unlikely because green cars are not too common. So how do we express probability? The probability of an equally likely outcome is simply the number of ways the outcome could occur divided by the total number of possible outcomes. So if I roll a die, for example, there are 6 numbers on the faces, so that means we have 6 possible outcomes. So if the probability of getting a 3 when you roll a dice is a 1 in 6, because there is only a single 3 on a dice. So the probability of getting a 3 when you roll a dice is a 1 in 6. So the formula is the number of ways the outcome could occur, which is 1, divided by the total number of possible outcomes, which is 6. So the probability of getting a 3 when I roll a dice is equal to 1/6. Also, the probability of getting a 5 when I roll a dice is a 1 in 6 because there is only a single 5 on a dice. So the probability of getting a 5 is equal to 1/6. The next thing we need to talk about is the probabilities of events not occurring. Now, if one outcome is the opposite of another outcome, such as raining and not raining, winning and losing, then the probability of these outcomes add up to 1. For example, if I say that the probability of a student passing an exam is P, of course, you know that the opposite of a student passing an exam is failing an exam. So the probability that the student will fail an exam will be 1 minus P. So whenever you have one outcome as the opposite of the other outcome, then the probabilities of these two outcomes add up to 1. Now let's take a look at the first example. It says that the probability that a man washes his car on Friday is 0.7, what is the probability that he does not wash his car on Friday? Now remember that these two outcomes are the opposite of each other, so the probabilities add up to 1. So to find the probability that he does not wash his car on Friday, all you need to do is to subtract 0.7 from 1, because I mentioned earlier that if one outcome is the opposite of another outcome, then the probabilities of these two outcomes add up to 1. So to get the probability that it does not wash his car on Friday, you simply do 1 minus 0.7, and that will give you 0.3. Now to confirm if what you've done is right, you need to take the sum of the two outcomes, the probability that the man washes his car and the probability that he does not wash his car. That's 0.7 plus 0.3. You should get 1. Here's another example. It says a bag contains 20 smartphones. Some are black colored and the others are white colored. The probability of picking a black colored smartphone is 4 over 5. What is the probability of picking a white colored smartphone? Now, if you look at the question, you discover that we have just two colors. We have a black colored smartphone and a white colored smartphone. Now you discover that one of them is the opposite of the other. So to get the probability of picking a white colored smartphone, you do the same thing. Remember from the previous slide, I said that if one outcome is the opposite of another outcome, then the sum of the two outcomes add up to 1. So to get the probability of picking a white colored smartphone, all we need to do is to subtract 4 over 5 from 1, and that will give us 1 over 5. Example 3. When you roll a dice, what is the probability of scoring a number under 5? And what is the probability of not scoring a number under 5? Now there are 4 possible outcomes that give you a number less than 5. Of course, you know that in a dice, we have it numbered from 1 to 6. So the probability of getting or scoring a number under 5 is simply 1, 2, 3, and 4. That is the number of ways the outcome could occur. So there are 4 possible outcomes that give you a number less than 5. That is 1, 2, 3, and 4. And the total number of possible outcomes you can get in a dice is 6, because you have a dice numbered from 1 to 6. So to find the probability of scoring a number less than 5, you simply do the number of ways the outcome could occur, which is 4, divided by the total number of possible outcomes. You have 6 faces in a die, so that is 4 divided by 6. Then when you simplify, you get 2 over 3. Now the probability of not scoring a number less than 5, this case is the same thing with what we discussed in the previous slide, because one of the outcome is the opposite of the other outcome. So since you've been able to calculate the probability of scoring a number less than 5, to get the probability of not scoring a number less than 5, you simply subtract 2 over 3 from 1, and that gives you 1 over 3. Example 4. A box contains a set of cards numbered 1 to 10. One card is picked at random. What is the probability that the number on it is less than 7? And what is the probability that the number on it is even? Now the first thing you need to do is to find out the total number of possible outcomes you have. Now since the box contains a set of cards numbered 1 to 10, so it means that there are 10 different possible outcomes altogether. And we need to find out the number of ways possible we can get a number on it less than 7. So there are 6 possible outcomes that give you a number less than 7, because you have 1, 2, 3, 4, 5, and 6 to be less than 7. So to calculate the probability that the number on it is less than 7, you simply do 6 divided by 10. 6 is the number of ways the outcome could occur, that is the numbers you have that are less than 7, and 10 is the total number of possible outcomes you have. So that is 6 divided by 10. When you simplify, you get 3 over 5. Now for the second one, to get the probability that the number on it is even. Now the even numbers we have between 1 to 10 are 2, 4, 6, 8, 10. Now, if you count the numbers, we have 5 of them. So the number of ways possible you can get an even number between 1 to 10 is 5. So that's 5 divided by 10. 10 is the total number of possible outcomes you have. So 5 divided by 10, when you simplify, you get 1 over 2. Example 5. You can spin any number from 1 to 6 on this spinner. Write a number that is impossible to spin. Now, if you look at the spinner closely, you discover that it is numbered from 1 to 6. So for us to get a number that is impossible to spin, it is going to be any number less than 1 or greater than 6. Question 2 says, what is the probability of spinning an odd number? Now, the first thing you need to get is the total number of possible outcomes. Since we have 6 numbers on the spinner, it simply means that we have 6 possible outcomes. Now, the probability of spinning an odd number is 3, because checking on the spinner, we have 3 odd numbers, which is 1, 3, and 5. So the number of ways possible is 3 for getting an odd number on the spinner. So that's 3 divided by 6. 6 is the total number of possible outcomes. So 3 divided by 6, when you simplify, you get 1 over 2. Now, what is the probability of spinning an even number? Now, on the spinner, we have 3 even numbers, which are 2, 4, and 6. So the number of ways possible for getting an even number is 3. So that is 3 divided by the total number of possible outcomes, which is 6. 3 divided by 6, when you simplify, you get 1 over 2. And finally, what is the probability of spinning a number less than 6? Now, a number less than 6 on the spinner could mean you have 1, 2, 3, 4, and 5. You have a total number of 5 numbers, and that is 5 divided by 6. So you need to always remember that to find the probability of an equally likely outcome, you need to simply do the number of ways possible divided by the total number of possible outcomes. That is all for today. Thank you for listening.